The second side of Handout 4 deals with rational expressions. So we've got to simplify some rational expressions first. So let's take a look at our first problem here. And when I look at it, I see that there's a prime number here for the last term. So that's what I'm going to start off with. So as I look at that, I see that 3 times 1 makes 3. Now I know the outside and inside terms need to subtract to make 4. And so what I'm guessing is it's going to end up being a 2x and a 2x. You see how the inside terms make 6x and the outside make 2x, and that will subtract to make 4. Now in order to make it negative though, make the 3 negative and the 1 positive, so that does end up working out. Now here this is a difference of squares, so if it's a difference of squares, the only binomial that will factor as two binomials will be a difference of squares, and it does factor to a 2x minus 3 and a 2x plus 3. Same numbers, just opposite signs. And so from that point you can take out those 2x minus 3's, and we're just left with that 2x plus 1 all over the 2x plus 3. And that would be our answer. So looking at our next one here, we've got some common factors up top. So I see 5m squared. We can divide each of those terms by. So take out that 5m squared, put that on the outside of a set of parentheses, do some division, and we've got the m plus 2 left over. Now down below it's a trinomial. It doesn't have a common factor, but it does factor as two binomials, and it does factor to an m plus 2 and an m plus 1. So at this stage we go ahead and take out those m plus 2's, and all we're left with is an 5m squared over m plus 1, and that would be our answer. Well, here this looks like a strange multiplication problem, but that's what it is. It just has some parentheses around it rather than that dot representing multiplication. So here we're going to take out a common factor. 4x is what I see, and so I'll take that 4x, put it on the outside of a parenthesis, do the division, and we've got an x plus 2 left over. Now up on top of the next fraction, it's a difference of squares. It factors to a sum and a difference, or a difference and a sum, depending on which way you write it, like I did there. And we look down below, and I see this trinomial doesn't have a common factor, but we can factor it as two binomials, x plus 4 and an x plus 3. And over here, there's a common factor of 7x squared. So take that 7x squared, put it on the outside of a parenthesis, and then do some division. So what's left over? Well, we've got an x plus 2. So we go ahead and take out those common factors that we see. So looking at this, I see an x plus 4 cancels out an x plus 2, and I see this x will cancel out the x, one of the x's down below. So what's left over? Well, we've got a 4 and then an x minus 4. That's on top. Down below we've got a 7 and 7x. So let's fix that real quick. So we've got 7x and a x plus 3. So you can leave the answer this way, but you might end up seeing it being multiplied. So that would be a 4x minus 16. And then down below is 7x squared plus 21x. So either answer is fine. I would take either one. But on a multiple choice test, it's going to be one or the other. Well, here's a division problem. So when we see division, we'll change it to multiplication. And then we're going to take the reciprocal of that second fraction. So take out the common factor first. We see 2 goes into these numbers, so x minus 2 is left over there. And we have a common factor here as well, so just x. So take out that x, and what's left over is an x plus 5. So just because it has a quantity being squared doesn't mean it is a factors as two binomials. In this case, just one set of binomials for that one expression. Here we have a common factor of x squared, so you're going to pull out that x squared. Now when you do it, the common mistake is people just put an x here. But that's not what we have. We have to have two terms. So x squared over x squared makes 1, so it should be a minus 1 there. That trinomial factors to an x plus 5 and an x minus 2. Now we're ready to cancel out some common terms. X minus 2's cancel out. X plus 5's, this 1x here will take away 1x from the bottom. So what's left over? Well, we've got the 2 over x minus 1. And then that x minus 1 is being multiplied by the remaining x. So you could see the answer that way. Or 2 over x squared minus x is another way to write that answer. Well, this one looks a little different. What we want to do is simplify the numerator first, then we'll do some division. So let's do that. So this side over here needs a 4. So I'm going to multiply it by 4/4. And this side needs a 3. So I'll multiply by 3/3. And so what I've got now is 4x plus 3x all over 12. So you see how 4 times x made the 4x, 3 times x made the 3x. I just wrote it over one fraction because that's what the denominators are both, 12. And so I can go ahead and add those two numbers together. I'll go ahead and rewrite what I've got. And so that makes a 7x over 12. Now, this division sign, or any division sign, is the same as this division sign. So let's go ahead and rewrite it using that division sign. It might make it a little bit easier for you to see what to do. So if you're a little confused with the fraction bar, change it to a division sign like you're normally used to seeing. And now you can do it just like we did the last one. So just take that reciprocal of that second fraction, change it to multiplication. See what cancels out. And so what we can see in this case is that the 21 and the 7 have a common factor. So 21 changes to 3, and the x's cancel out as well. So let's see what's left over. We got 5, and then 12 times 3 makes 36. So 536 is our answer. Next problem here, we've got to come up with a common denominator, just like we did on this last problem here. However, we've got an expression as the denominator. Well, x plus 1 and x minus 1 don't have anything in common, so we have to multiply by the other's denominator. Now, be careful on this one when you do it. You've got to use the distributive property. So it's 3x squared plus 3x. Now, in this one here, think of this as like a -5. Distribute it. If that's a minus, change it to addition. Make sure that numerator changes to a negative, and then distribute. -5x plus 5. Now, this is all over x plus 1 and a x minus 1. So what you're going to end up doing from this point is you're going to collect like terms. So we see that we have a 3x here and a -5x. So what we've got now is 3x squared, a minus 2x, and a plus 5. Now don't worry about trying to factor it. It's not going to factor and cancel at all, so we just got an x plus 1 and an x minus 1 down below. So you can leave the answer like this, or you could even rewrite it as 3x squared minus 2x plus 5, and then multiply out those two binomials. Happens to be a difference of squares, so the outside and inside terms cancel. So either way would be fine. Those are some of the problems that you'll see on tonight's homework, which is handout number 4. So that's the back side. Front side was on part 1.